All right. Well, welcome, folks. So today's session, we are going to actually work on VISSIM, which is a traffic modeling software. We've talked about this a little bit. And for today's lab, I'm giving you step-by-step instructions, and that is posted online. And I see a lot of you have actually opened that. So this is, I can share my screen real quick. Let me share my screen from here. Second. Share my screen. So, okay, yeah, so you should be, if you go to your Canvas portal, you go to your Canvas portal, you can find that under lab 2, in your CE 529 tabs under lab 2, you can find the tutorial. And if you click on that, it takes you to a Google Doc. Basically provides you with the step-by-step instructions of what we are trying to do. Now, what's going to happen here is that you're going to essentially build a network like this. So here and if you can, so what you're going to actually do here is that you're going to create a network that looks like this. Just two intersections, a major road intersecting with two streets. You can create it anywhere. And for today, we're going to try to make this intersection into, this will be your major road, and then these two will be your minor road. Okay, so you're going to put stop sign over here, you're going to put stop sign over here, stop sign over here, and stop sign over here. So you're going to put 4 different stop signs, one here, one here, one here, and one here, and you're going to turn into a stop control sort of intersection. Okay, so you're going to model 2 intersections, and you're going to model this whole network. And if you're wondering, like, why didn't we not start with maybe doing something like this? So instead of like modeling this, why don't we just start off with just one intersection like that? Because the idea of like, if you just do one intersection, and at that point, the idea of origin's destination is too simplistic. Yeah? Because if you only have one intersection, your turning movement counts become your OD flow, become your origin destination. So if you look at just this one intersection, you're essentially dealing with an origin over here, an origin over here, an origin destination over here, and then this origin destination over here. Okay, so you have these sort of, you can think of these locations as 4 zones. Okay? And each of these zones serve as origins and destinations. Now, that, and because I don't want you to think about when you're modeling a network in terms of turning movement counts, I want you to start out by modeling a network like this, where your origin destination points will be actually how many? How many OD do you see here? How many OD, not OD pairs, just how many nodes, I mean, how many points do you see that can serve as origin or destination in this bigger network? This network. 6, right? Right. So you can see 6 of these locations. So your goal will be to kind of create a network that has these 6. And that's why if you go back to your tutorial, when I give you the demand, yeah. If you look at the demand, I give you sort of 6 origins and 6 destinations. So I give you like a 6x6 matrix of the travel demand. Okay. It's not exactly sort of travel demand, but you know, you get to see when you read it. Because when you're modeling this, when you're modeling this, now you're going to be able to create routes to different destinations. So for example, there would be, we have a different color here. You'll be able to create routes. You'll be able to create a route that goes here. Okay, so that's your one route. The other route will be starting from here, going over here. The other route could be starting from here, going up all the way up to here. That's your 3 locations. One will be simple, straightforward 4. And then 5. So, and in this case, you cannot travel from same origin to same destination. Because obviously, this is a very small network. So for each origin point, you'll be creating 5 different destinations. And these are the routes that you'll have to define in VISSIM. And for each of these routes. So the way we model things in VISSIM, you will see that you'll have like a network vehicle input point. So vehicle input point, there will be 6 of them. Okay, 6 vehicle input points. And for each of the vehicle input points, you will get 5 destinations. And that's where that table that I was just showing you will come in handy, is that your input volume is a separate tab that decides how much total volume comes in from here. And then when you split them apart, that's where the total destination volume goes. Okay? And then, so that sort of is the main difference between a VISSIM model or something that you might be doing in Synchro, for example. So in Synchro, you're typically entering, for each intersection, you're entering turning movement. I think this represents the model more realistically in terms of, like, you know, the overall origin destination flow. So that's where we're going to start. So what I'll do is, what I'm expecting you to do is open that Google Doc, open that VISSIM file, and then basically just start following the steps. If something's not clear, we have Vaishnavi here who took this class last year. You know, wave your hand, Vaishnavi. Yeah. So she can answer some questions. I can also answer questions. And I think one thing that you might do is, like, if you have questions, I'm also on the Zoom call right now. So if you have questions, then maybe you want to hop on Zoom and share the screen and things like that. That sometimes works easier. And then what we can do is, if there are sort of same types of questions that are coming up, you know, based on your consent and based on, like, you know, if I notice that this might be a problem for everybody, I can just sort of share that concern with everybody. So let's go ahead and build this model by following the steps. So there is no submission for this lab. For this lab, all you have to do is, once you're done with the network, you just show me the network that, hey, I'm done with it. And then I'll give you the full credit for it. Okay. So take your time, no rush, like, you know, just play around with it. Don't think that you have to follow these steps. If you get a little bit sidetracked, it's okay today, but it's not okay tomorrow. I mean, on Thursday. I do need this lab by Thursday, end of the lab Thursday. So yes, the tutorial is a starting point. Have fun with it. It's a very interesting sort of thing. Maybe you wanna, like, instead of like completing all the steps, maybe you just want to jump in and start to see vehicles moving. That's perfectly fine. Whatever you want to do, just play around with it. But as you run into questions, let us know. And then if you think that there is something that we can help you, we will. And again, don't tie yourself to these steps for now. Just have some fun with it. And then maybe on Thursday, we can all get serious and make sure that we can finish the steps too. Okay? So yeah, let me know what's happening and we can go from there. And one more thing is, for today's network, you can draw it anywhere, like anywhere in the world, really. It doesn't matter where you draw it. You can pick a real location if you want, but if you don't want it, that's okay too. You could just draw these links in a wilderness anywhere on the ocean. I don't care. But anytime you have a location in mind, then you zoom into that location. And okay, can I have like a quick minute with everybody? Just want to make it clear that, so input volume is different than your routing sort of strategy or routing distribution or whatever. right? So input volume is something that you input on one point of the network, usually at the starting point. So you'll have 6 different input volumes, and they will come in. So that's where vehicles enter the network. And then where they go, that depends on your routing strategy and routing, so routes that you will create. So even though you see the matrix first, so let me quickly show it to you here. So I can share screen. Okay, let's go. So if I go back here, so even though you see this matrix doesn't come into play. Oops, you're not seeing that. That's not good. Because I'm in the wrong screen. Okay, perfect. So let's stop here. I'm sharing from my laptop, which doesn't make sense. Okay, let me go back here. Sharing. So yeah, this is what you should see. So if you see here, so these 60, 60, 80, 60, 50, and 100, these are your input volumes. These are the numbers of cars that are going to enter the network from these 6 points. Okay? Now, how they're going to split themselves is what is decided in that matrix here in table 1. That's just relative flow in percentages. And you can see, like, whatever your zone 3 is, and you can see that what zone 3 looks like. So zone 3 in this figure was from up top here. So from zone 3, most of the traffic is going to zone 2, right? 75% of the traffic is going to zone 2. So basically, from 3 to 2, from this 3 to this 2, there will be 75% of the cars or vehicles will be going to this point. And then rest of them are going to be on the basis of, I think you get the right turn to 10% are going to zone 1, and then rest of them are 5. So then there will be 10% who are going to be turning right here. And then you put 5% going here, 5% going back to number 5, and 5% going to number 4. Okay? So 5% will be going to 6, 5% going to 5, and then 5% also going to 4. Now, this step, these percentages only come into play when you do this routing decision points. Okay? So for each origin points, each volume input point, you're going to start a route there. That becomes your origin, and then you just sort of draw out the path to the 5 destinations. Okay? And then for each of those destinations, that's where you enter those percentages that I just showed you. So you could see, like, for example, so this is what will happen at the end. When you've created those 5 routes, this is what those relative flows look like. Now, you might be thinking, why do these relative flow look like sort of these small numbers? That's the thing about VISSIM, is that it only cares about what's the relative ratio of the numbers here. So for example, if this is the numbers you are trying to enter, like 10, 75, 5, 5, and 5, if you just divide everything by 15 and enter 2 or 5, divide everything by 5 and enter 2, 15, 1, 1, and 1, the end result would be the same. All you have to do is maintain that ratio. It doesn't matter if your numbers look like this, as long as my end result is that I get that percentage of vehicles to zone 3, that percentage of vehicles to zone 2, and those percentages of vehicles to zone 4, 5, and 6. So key ideas here is that your input volume happens first, decides how many vehicles are going to enter the network from each of the 6 origin points. And for all of those 6 origin points, then you have to define 5 routes that take you to 5 different destinations. So in all, you're in fact going to be defining how many routes? 30 routes. For each origin, 5 different routes. And then Once you've defined those routes, the relative flow is where you enter those percentages. Okay. And again, you don't have to. So I'm showing you that instead of doing 10, 70, 50, 50, and 10, I think this is a different one. But I could have done 1, 7, 5, 5, and 10. Right? As long as the relative ratio is the same between these relative flows, you're going to be okay. They can add up. They don't have to add up to 100. They don't have to add up to anything, as long as you're able to maintain that correct ratio. Okay? So you can directly take the numbers from the table. You can divide them by 10. You can divide them all by 5. It doesn't matter. It's going to be fine. Okay. So just wanted to make sure that this is clear. So you can go ahead and continue.